Alright, we are about halfway through our unit on functions. Hopefully all of you are having fun. Alright, really though, all jokes aside, today we're going to take those parent functions that we studied in the last unit and we are going to start transforming them, which means we're going to move them around the coordinate grid. There's two different types of transformations that we are going to talk about. The first is rigid transformations, and those are where the graph holds its shape. So within rigid transformations you can talk about shifting, and you can also talk about reflecting. Those are the two we're going to focus on today. We can also talk about non-rigid transformations in which your graph becomes distorted. So you're talking about the same general shape, but you have stretched it or you have shrunk it, and that will be in our next lesson. So in addition to having rigid and non-rigid transformations, you can have these transformations that occur inside the function, which will create some sort of a horizontal change. Or you can talk about changes that happen outside of the function, which will result in a vertical change. So horizontal and vertical changes. First, let's review a little bit of function notation. So remember, f of x represents the same thing as your y value. In this case, x is our input, so it's independent variable. We choose the value for x. Then, after picking an x value, you start applying the function to it, which creates your y value. So in this function, we're going to take our x, and we are going to apply the function of cubing. Then we're going to add 1. So to find f of -3, we're going to take -3, cube it, and add 1. Order of operations gives us a -26. f of x plus 1, again, we're going to take the x plus 1, we're going to replace our x value, then we're going to apply the function of cubing, and then add 1. This would be the same thing as taking x plus 1 3 times over, distributing, and then adding 1, which I'll let you do on your own time. So within rigid transformations, I said there's two different types, shifting and there is reflecting. So we're going to start with shifting. Horizontal shifts are going to happen inside the function, which means it's going to happen before you actually apply the cubing or the squaring or the absolute value, whatever it might be. So shifting right, we're going to take f of x minus c, and shifting left, we're going to take f of x plus c. Now you may be asking yourself, well, shouldn't a negative sign move something to the left? You would be correct in your thought process until you think about the fact that we haven't yet applied the function. So if I think about my parent function of x squared, which we know looks like a parabola, and I say instead I want to take f of x minus, we'll say 2, and square it. Well, what does that actually do? If we set that equal to 0, we could find our zeros are going to be at x equals 2, which means that this point right here is going to move over 2 units. In which direction have I shifted it? I've shifted it to the right. So these ones are a little bit outside of what your intuition would tell you. You're going to move it to go right, you're going to subtract. To move left, you're going to add. Vertical shifts are going to happen outside of the function. So you're going to pick an x value, plug it in, apply the function, then you're going to shift it down or shift it up. So we would take our function as it is after we've applied it, and then we would subtract our value. Or we're going to take our function, get our y value, and then add to move it up. So think about this being your y value. You're going to find that y and then move it down however many units. You're going to find that y and then move it up a number of units. So given these three functions, describe these in terms of your parent function being f of x. So f of x is just x to the 4th, whatever that graph might look like. Okay. H of x says we're going to take x to the 4th and then subtract 1. Well, to rewrite h of x then, x to the 4th is the same thing as f of x. So I could rewrite that instead as f of x minus 1. I made a substitution. So really this is moving the function down 1, because you're finding your y value and then subtracting 1. g of x, on the other hand, I'm going to change colors here. I'm taking x plus 1, and then I'm applying the function. So this is happening inside before we ever apply that fourth power, which means I'm taking x for what it was, and I now want to see x plus 1. So I'm going to take f of x plus 1. Thinking about what we know how to apply function notation, that would be the same thing as taking x plus 1 and raising it to the fourth power, which is what g of x is. Now, if you think about this in terms of notation, this is all happening inside our function f, which means we're going to go against what we think it should be, and instead of moving to the right one, we're going to move to the left one. The other type of transformation that does not change the shape at all is reflecting. So our first reflection can happen over the y-axis, which is going to result in mirroring over the left or the right. So when I pick my x value, let's say I want to see what happens when x is 2. Well, I want to mirror that. So instead of 2, I'm actually going to plug in -2, because I'm going to mirror it over the y-axis. So this is going to happen inside the function. Instead of taking f of x, I'm going to take f of the opposite of x. Note that that also works if originally I said I want to find f of -3. Well, to mirror it over the y-axis, I would actually want f of +3, which would be taking the opposite of that x value. To reflect then over the x-axis, it's going to mirror the top to the bottom, which means I want to actually find my y value, and then I want to take that y value and flip it over the x-axis, so I want to end up down here instead. Well, that's the same thing as finding your y value, which is f of x, then saying, nope, I actually want the opposite of it. So if this y value was 3, I would say, nope, I want -3. Likewise, if the y value had been -3, I would say, nope, I want +3. So again, inside the function is flipping left and right, outside the function is flipping top to bottom, or bottom to top. Identify the parent function, describe the transformation, and graph the functions. We're going to do a little bit of curve sketching here. First of all, you have to think about your starting variable of x. What is the overall function being done to x? Well, the parent function is going to be taking that square root. So, part A. Our parent function is f of x is the square root of x. So we got part A down. Now I want to know what's happening to f of x. What am I doing to it? Well, starting on the inside and working your way out, the first thing you're going to do to x is add 1, and that's all happening before you take a square root. So we would say this is happening inside the function, and when you're adding inside the function, that's going to move left 1 unit. Then after I move left 1 unit, this negative sign on the outside, notice I said outside the function, is going to do some sort of reflecting. Since it's outside, it's going to reflect over, my apologies, that should be reflecting over the x-axis. Hopefully you caught that before I did. Then the last thing I'm doing is I've got this 2 out here, and realistically I'm adding 2 to the outside. Again, it's outside the square root, so that's going to be a vertical change, and since I'm adding, I'm going to say we're moving up 2. So, in order to graph this function, we have to consider all of the different pieces. I'm going to start by graphing the parent function, the square root of x. Then the first thing I'm going to do is I'm going to move that whole parent function to the left 1. After I move it to the left 1, I need to reflect it over the y-axis. Sorry, x-axis, I keep saying that. X-axis. And then I want to take that whole graph, and I want to move each one of those points up 2. So this red one is our final product. We've taken the square root function, we've moved it to the left one, we've reflected it in the x-axis, and we've moved it up 2. Identify the parent function and the transformed function. So I'm going to ask you to pause your video and apply what we've learned and see if you can identify parent function and how it's been transformed. Alright, so hopefully you identified that your parent function was the square root, or sorry, the absolute value of x. It's got that V shape to it. But now we've got to consider what we've done to that overall shape. Well, it's definitely moved to the right one. Instead of opening up, it's now opening down, and we've moved it up 3. So those are my 3 transformations that happened to my function. Thinking about that in terms of writing a new function, I'm going to take an x value. I'm going to move it to the right one, so I want to subtract 1 from it. I'm going to take the absolute value of it. I'm going to reflect it. Then I'm going to add 3. So this was our function. This change happens inside. These two are happening outside. So horizontal change, vertical change, vertical change. Alright, this one we're going to be reading our transformations from an equation, and we've got to apply them to this graph of f. So, starting from the inside out, the first thing we want to do is we're going to say, instead of taking f of x, we want to take f of x plus 1. Well, that's all happening inside this function f, so that means we're going to move everything to the left 1. So I'm going to move just a few key points so that I know how to resketch in my graph. So there's moving to the left 1. Then, after I move this function to the left 1, I'm going to take the absolute value of it. I'm actually going to do that in green so you can see it better. Well, what does taking the absolute value do? It takes any positive number and keeps it positive, takes any negative number and makes it positive, because you're talking about distance. Well, these are all positive values until here. So now I want to take all of these negative y values, and I instead want to make them positive. These ones are all positive, so those will stay. These are all positive, those will stay, because they're all above the x-axis. But then these negative y values, I want to move them up. See, we're at -6, that'll be a +6. And reflect those up. Okay, so that's because of this absolute value that's happening. Then the very last piece says, after all of that, you're going to subtract 3. So I'm going to subtract 3 from a y value, subtract 3 from my y value. 1, 2, 3. And the yellow one is your final product. If you think about the yellow in relation to the blue, we have not changed the shape at all. We've just moved it around the graph to create this new picture. So horizontal happens inside the function. Vertical changes happen outside because they are after you've found a y value. That concludes your shifting and reflecting. Next video we'll talk about the stretching.